Hello and welcome back to Duncan Codes. Today we're going to be continuing with the University of Helsinki's massive open online course, and we're looking at part 4, which is the object orientated programming section. And we're going to start here with calling a method. Now the calling method I've already got completed because I thought I was recording and I wasn't, but I'll go through the answer just to give a bit of context to those of you that aren't sure. So if we look here, we've got our public class student and we've got private in credits and in our two methods. We've got the constructor, which we can tell because it's got the capital S and it's the same name as the class, and then we've got our void play as well. So when we're creating a new object, we use the class name followed by the object name, then equals new class name. So when we're using a scanner, we do scanner scan equals new scan. And here we've got student mat equals new student. Now it wouldn't be the first answer because the object name is mat, not student, so it wouldn't be student.play. And if we have a look at the other options, we can see that we've got mat.play without parentheses. Now that's not going to be the correct one because a method does need parentheses. We've got student.play, again, which is not correct because it's the class name rather than the object name. And then we've just got a method.play here. So we need to have our object, which is mat, and then the method. So it's mat.play. So let's move on to the creating a class section. A class specifies what the objects instantiated from it are like. The object's variables or instance variables specify the internal state of the object, and the object's methods specify what the object does. We'll now familiarise ourselves with creating our own classes and defining the variable that belong to them. A class is defined to represent a meaningful entity, where a meaningful entity often refers to a real-world object or concept. If a computer program had to process personal information, it would perhaps be meaningful to define a separate class person, consisting of methods and attributes related to an individual. Let's begin. We'll assume here that we have a project template that has an empty main program. In NetBeans, a new class can be created by going to the Project section located on the left, right-clicking New, and then Java Class. The class is provided a name in the dialog box that opens. As with variables and methods, the name of the class should be as descriptive as possible. It's usual for a class to live on and take on different forms as a program develops. As such, the class may have to be renamed at some point later. Let's create a class named Person. For this class, we can create a separate file named person.java. Our program now consists of two separate files since the main program is also in its own file. The person.java file initially contains the class definition, public class person, and the curly brackets that confine the contents of the class. So if we look just below this paragraph here, we can see that we've got this blank class. In fact, what I'll do is I'll open Apache NetBeans and I'll go through, we'll follow this example in Apache NetBeans. So here we go, we've got NetBeans open. I've got these open from the last time we had looked at objects and classes, so let's get rid of those and then I'll create the new person class. So at the moment I've got a Git example class, and you can see that's our main class because it's got the main method in it. And to create a new class, what I'm going to do is right click on the project, then hover over new, and then from there move to the right and select Java class, and then we get the pop-up. If you haven't got Java class listed, you can click other and it will bring up this pop-up here, which will allow you to choose from all different Java classes and files. But I'm just going to right click on it again on the project, go to new Java class, and then I'm going to rename it person and click finish, and you can see that we've been given a blank person class. You can see that the person.java is in green, and that means that it's a tracked Git project and that we've got changes. And the changes are that we've actually just created the class. So you can see that we've got on line 6 on both of the classes open. You can see that they both belong to the same package called Git example, and then that we've got that blank person class there. After creating a new file in NetBeans, the current state is as follows. In the image below, the class person has been added to the sandbox exercise. So you can see in their example they've got two classes, application.java and person.java. You can also draw a class diagram to depict a class, and we'll become familiar with its notations as we go along. An empty person named class looks like this, so it's just that square box with person written in it. A class defines the attributes and behaviours of objects that are created from it. Let's decide that each person object has a name and an age. It's natural to represent the name as a string and the age as an integer. Right, so I'll just go to my projects. Let's put these side by side so we can see what we're up to. There we go. So what we can do now is add in these two private strings, these two private data types, and because they're private, there's something called encapsulated variables, and what that means is that they're contained just within this person class, and we won't be able to access them outside of the class. What I'll do is I'll just pop these two variables in, and then I'll add another example. So I'll put in a static string, and I'll call that family name, and now you can see that's gone purple. So that means that it's globally accessible. So if I head to our main now, so I'll type in person.family_name, and you can see that it's found that variable, but when we typed in person, it didn't give us the name and age from the drop-down list. We couldn't choose those because they are marked as private, so they cannot be seen outside of the person class. We specify above that each object created from the person class has a name and an age. Variables defined inside a class are called instance variables, or object fields, or object attributes. Other names also seem to exist. There's quite a lot of words that are used interchangeably in programming and databases as well, and you'll find sort of methods, functions, subroutines or routines and things like that quite often used interchangeably. Instance variables are written on the lines following the class definition, public, class, person. Each variable is preceded by the keyword private. The private keyword means that the variables are hidden inside the object, and this is known as encapsulation. So if you think of a capsule, so a medication capsule, quite often they come in the sort of sugar-coated capsule, and then they have the medication inside. That medication, you could say, is encapsulated within the capsule. If you imagine on here that our class is the capsule, and then our variables and methods inside are the medication encapsulated within the class. Encapsulation is one of the four sort of cornerstones of object-oriented programming, and I'm sure we'll be using it and visiting it later on as well. In the class diagram, the variables associated with the class are defined as variable name, variable type. The minus sign before the variable name indicates that the variable is encapsulated, so that means that it has to be private. In class diagrams, we have a minus for private, a plus for positive, and an octothorpe or hashtag for package private, I believe it is. We have now defined a blueprint or a class for the person object. Each new person object has variable name and age, which are able to hold object-specific values. The state of a person consists of the values assigned to their name and age. Excellent, our first exercise. A new class can be added in NetBeans in the following way. So that's given us example, explaining to us how to right-click and things. So let's get the projects open and find the dog attributes. Oops, I'm looking at the files. And then open up our dog attributes one. So there should be, I presume, one class in there at the moment. There we go. And then we need to right-click. Actually, what we can quickly do is get our GitHub and Git bash all sorted quickly. So I'm just going to copy the file location from here. I'm going to open Explorer window and navigate to the MOOC Java folder. You can see we've got our .git folder there. So I'm going to copy that link. I'm going to do cd for change directory, double quote, paste in the link, and then double quote again, and you can see that it's changed our working directory there. Okay, so I'm going to do git add, just in case there's anything new to add. and then git commit -m, and then double quotes, and inside the double quotes I'll put a little message, and this will actually tell us if there are any changes. So you can see it says that your branch is up to date, so there's nothing to commit. There we go. So I'll move that to the side quickly. And let's have a look. Right, so we need to create our new dog class. And once we've created that, we need to add the private variables, string name, private breed, and private age. So let's call it dog. So actually, I just put a typo in there. It doesn't actually matter if you put a typo in, so I'll quickly show you how to resolve that. So you can see that the class name is doff. If we select it and press Ctrl and R for rename on the keyboard, it will bring up the rename option, or you can right click, go to refactor, and then you can see rename is there with the Ctrl and R next to it if you want to use the shortcut. So I'm just going to rename that, press refactor, there we go. So it's changed it here in the class, but also under the package as well. You can see that it's changed the dog class up there. Right, let's have a look and see what variables we need to create. So we can take the variables from the challenge, but we can also see that we've got the class here as well, the class diagram. So we've done the bit where we name it dog. We've got a hyphen sign, name, and then name is of type string. So that means that it's a private string called name. We've got a private breed, which is going to be a string as well, and then we've got a age, which is also going to be private. So let's add those in. Okay, so let's just quickly double check and see if we need to put anything else in. Doesn't look like we do. Okay, that's great. So let's give that a run locally and see what we get back. Excellent, we've passed. Let's give that a run against the servers, that's great. And let's have a look at this next section, defining a customer. We want to set an initial state for an object that's created. Custom objects are created the same way as objects from pre-made classes, such as ArrayList used in the new keyword. It would be convenient to pass values to the variables of that object as it's being created. For example, when creating a new person object, it's useful to be able to provide it with a name. So if we look here, we've got person Ada equals new person, and then in the brackets, we've got string literal Ada. So if we want to create our own constructor, what we can do is to write public, and then we would need to write the class name with a capital letter. So if I was to put person here, and then string initial name, for example, although that is syntactically, well, it's not syntactically correct because the constructor name is incorrect. So it shouldn't be person, that should actually be dog. But this is the sort of thing that we could write. So we would use the keyword this, followed by a variable. So we're going to do age, for example, name, and we can say that this.name is equal to the value that we're passing to it when we create the constructor, which is the initial name next to string. So you can see here that we've got the error, and just again, that is because the constructor is called person and it's not called dog. So what we can do is if we quickly change this to dog, like that, that makes it all good. So just to reiterate on this constructor, we've got the public dog with a capital D, and normally when you think we do anything we use camel case, so it should be a lowercase, so you can always tell a constructor. We're passing it one string, which is the initial name, and then the example that we saw on the previous one, it would be Ada, and then we're saying that this.age is equal to 0, and then this.name is equal to the value we're passing it from initial name. Okay, so let's continue with the University of Helsinki's description of a constructor. So the constructor is achieved by defining the method that creates the object, for example, its constructor. The constructor is defined after the instance variables. In the following example, a constructor is defined for the person class, which can be used to create a new person object. The constructor sets the age of the object being created to 0, and the string passed to the constructor as a parameter as its name. So that's the example that we went through just a moment ago. The constructor's name is always the same as the class name. The class in the example above is named person, so the constructor will also have to be named person. The constructor is also provided as a parameter the name of the person object to be created. The parameter is enclosed in parentheses and follows the constructor's name. The parentheses that contain optional parameters are followed by curly brackets. In between these brackets is the source code that the program executes when the constructor is called, e.g. new person Ada. Objects are always created using a constructor. A few things to note: the constructor can change the expression this.age equals 0, and like we discussed before, this expression sets the instant variable age of the newly created object, so the object's age, to 0. The second expression, this.name equals initial name, likewise assigns the string passed as a parameter to the instant variables of the object created. What I'll do is I'll open Apache NetBeans again, and we can continue with the example that the university are going through, and we can discuss the class diagram and maybe give a bit more context to the constructors as I type it out. So let's get that open quickly. So we've got our person class here. So what I'll do is just add in the variables. So it's private string name, and then private int age. And then if we look at the class diagram just towards the bottom right there, we've got the constructor person. So remember, the constructor has to have the same name as the class. So it'll be public person, and then we're passing one variable, which is string initial name. We're going to initially set some data here. So this.age is equal to 0, and we're going to say that this.name is equal to the variable that we pass when we call a constructor, so initial name. Okay. So we could actually, if we wanted, set age as a passed parameter as well. So if I just quickly change that there, you can see. But obviously in this example they don't want to just yet, that's fine. So I'll remove that. But just so you know, you can have more than one data type or one variable passed in a constructor, just like a normal method. So if I quickly get rid of that, I'll show you the autocomplete code. So you press Alt and Insert on your keyboard, and it brings up this little generate tool option, and the top one is constructor, and you can see here that we can generate our constructor and select what private variables, or whichever variables we've got, as passed arguments and parameters. So I'm just going to select the top one. I could select both of them. I'll do that just now for this example, and you can see that it generates the constructor for us. I'll just quickly delete these bits back so it's same as the one in the University of Helsinki's example. Oops, changed the wrong one. There we go. And it needs to be initial name, of course. If you look at the class diagram here on the right, just to quickly go over it, you can see that the rectangle or the square has been divided into 3 sections. The top section, person, is the class name. The middle section are the instance variables, and in those cases, because they've got the minus signs next to them, they're private. And then if you have a look at the person constructor, you'll see that we've got a plus there, and that it needs to be public. So you can see here that I've highlighted that we've got that public, and then it needs to receive one variable that we're passing to it, which is initial name. Right, let's move on to the next challenge, which is room. I'll get back to TMC NetBeans. Let's close down. Actually, let's leave that open just so we can follow the examples along. Let's quickly update our GitHub. So we've finished the dog attributes. So what we're going to do is git add full stop, and then we're going to do git commit, and we can write that we've completed part 4, section 3, or part 4 dog attributes, whichever you prefer. And then remember that needs to be surrounded with double quotes. And then the last thing that we can do is do our git push u origin and master. Okay, and then press enter, and then that should update our GitHub. So that's great. Let's just move that. Right, let's close this project down, and then we'll open the next project, the room one, and see what we've got to do. So it says create a class named room, add the variables private string code and private int seats to the class, then create a constructor called public room, which takes two arguments, which are string class code and int number of seats, through which variables are assigned to the instance variables. The class does not do much, however. In the following exercise, the objects instantiated from our class is already capable of printing text. Let's just right click and create our new class. So we're going to call that one room, aren't we? There we go. And now we can begin to add in our private variables. So remember, on the class diagram we've got a minus, which means it's a private variable. There we go, and that's of type string, and that's going to be called code. Then we're going to do private int, and that one's going to be called number of seats. And then lastly, we're going to add in the constructor, so that's going to be public, and it's going to be the same name as the class with a capital letter, so room. We need to pass one argument, which is going to be string class code. So sorry, we're not passing it one, we're passing it two, aren't we? It says plus room string comma int. So we're going to be passing it the string class code and then the int number of seats. What we need to do now is add our sort of this bits in here. So we're assigning the passed arguments to the instance variables. So we'll say this dot code equals class code, and then this dot number of seats equals number of seats. There we go. Let's give that a run locally and see what we get back. Okay, so we've got some passed but not all. So let's have a look at those, this error, and see what we need to do. Oh, I gave it the wrong name. There we go. Right, now let's run that. Excellent, we've passed that, so let's send that off to the server. Let's update our Git as well. So we'll do git add dot full stop, git commit, and let's just add that in. So it's git commit -m, and then we've completed part 4, exercise 4, which is called room. Oh my gosh, it's all going on. There we go, completed part 4, challenge 4. Let's wrap our double quotes there and then do our git push. So you can press up on the keyboard to get your previous entered commands, which is quite useful, so that's what I did there. Refresh for our points, and then let's have a look at this section about default constructors. If the programmer does not define a constructor for a class, Java automatically creates a default one for it. A default constructor is a constructor that doesn't do anything apart from creating the object. The object's variables remain uninitialized. Generally, the value of any object references will be null, meaning they do not point to anything, and the values of primitives will be 0. For example, an object can be created from the class below by making the call newPerson. If a constructor has been defined for a class, no default constructor exists. For the class below, calling newPerson would cause an error, as Java cannot find a constructor in that class that has no parameters. So if we think back to the example that we've been looking at in Apache NetBeans, we've got our person class and we've got also our person constructor. So what we can do from the main method is create a new person, and it's very similar to how we would create a scanner. So we would say, instead of scanner scan equals new scanner, we're going to say person name equals new person, and we're going to open and close some parentheses and put our semicolon on. So that fundamentally looks right, but what we're missing are the parameters or the arguments to go between the parentheses. So if we think back to our constructor, it had two variables. One was name, I believe, and the other was age. So we need to actually pass those through. So if you have a look at the error that we've got here, it's saying that it requires a particular type. So there we go. So if our constructor actually only needs one variable, which is the name. So if we go between our parentheses and open some double quotes, because it's a string, then we can put our name in, and then you can see that the error's gone. So let's have a look at this defining methods for an object section. We know how to create an object and initialize its variables. However, an object also needs methods to be able to do anything. As we've learned, a method is a name section of source code inside a class which can be invoked. So, continuing with the person example, we've got a new method added in, which is public void print person, and it's got a system out there, and inside there we've got this.name plus comma age plus this age plus years. So we're going to print out the information, the basic information that we're passing when we create or use the object or the constructor. A method is written inside of the class beneath the constructor. The method name is preceded by public void, since the method is intended to be visible to the outside world, and it does not need to return a value. Okay, so let's have a look at this objects and static modifier section. So we've used the modifier static in some of the methods that we've written. The static modifier indicates that the method in question does not belong to an object and therefore cannot be used to access any variables that belong to objects. Going forward, our methods will not include the static keyword if they're used to process information about objects created from a given class. If a method receives as a parameter all the variables whose values it uses, it can have a static modifier. In addition to the class name, instance variables, and constructor, the class diagram now also includes the method printPerson. Since the method comes with the public modifier, the method name is prefixed with a plus sign. No parameters are defined for the method, so nothing is put inside the method's parentheses. The method is also marked with information indicating that it does not return a value, so here is void. Right, so let's head back to our person example, and let's get that updated and add our new method in. So if we look again at the class diagram, we've got our two variables, string name, int age. We've got our constructor, which has got the capital P and is the same name as the person class. And now we're going to add in a public void print person, like so. And then we can put our system out in there. So let's just type that. So remember the shortcut for that is SOUT and then press tab on keyboard. Right, so now we need to add in our name variable, and then we need to use concatenation using the plus symbol, then our string literal, and then we'll concatenate that again with the age, and finally another bit of string on the end there. So what we can do now is head back to our main class, and perhaps we can add some more people in, or some more people objects, just so we can get used to using them, creating them, and just to give some more context and some different ideas. Oops, I forgot my semicolon there. Let's add that on. Let's add one more person in as well, actually. Let's just add them in. New person, and then in between our parentheses and double quotes, Stan, and then semicolon on the end there. Okay, so if we run this now, we won't get any printouts, although we've put the method in the class, and that's because we haven't actually invoked the method. We haven't asked the method specifically to run. So what we can actually do is use the object. So in this case, we've got Duncan, Derek, and Stan, all objects, and then we can use the printPerson function, or method, sorry, from the person class. Okay, so let's just add those in. And now if we run it, okay, so I've got null, so I must have failed to update one of my variables somewhere. So let's have a look back at the person class. And okay, so you can see in the constructor, it says this.name equals name. So I'm updating the value with a null value, and it should be this.name equals initial name. Okay, so let's get those updated quickly. There we are. Right, I'll just copy the same typo in both of them, that's fine. Let's give that a run. And there you go, you can see that their information is now pulling through correctly as we expect. So that is great. I'm going to end the video here. We've covered quite a lot of different things today in regards to object-oriented programming. So it seems like now at the moment is a good time to pause before we start the next exercise. Hopefully that's been of use to you and made some sense. As always, if there are any sort of questions that you have, if there's anything that I haven't been especially clear on, or you think that I could explain in a different way, then please feel free to ask. But until next time, good luck and happy coding.